Hello. Hello everyone. Welcome back to my YouTube channel Remote Sensing GI Show. How all are doing well? So today we are going to learn a very amazing topic, how to create land use land cover map from the MODIS data. A step by step tutorial. Okay. After the tutorial, you have learned lot of things. So next, this video will be covered. At first, we have learned how to process the LULC data. Okay, because you know that to process the LULC data, there is the different step. Then go to how to classify the LULC data, and also learn about the collection of the data. So you know the MODIS have a different type of layer, different type of output. So in this tutorial, we have using the MODIS combined data, that is MODIS Tera and Aqua, and file size is 15 MB, and this is the very good thing, the temporal extent from 2001 to 2021. You guys can imagine, you can get the data 2001 to 2021. Okay, and the projection system or coordinate system is sinusoidal, and it is covered globally, and geographic dimension 1200 kilometer into 1200 kilometer. Okay, so about granular details, so you know or don't know, that is not required. After the video you will know the all about the things. So granular means the MODIS data have a different type of layer. Okay, so in this video there is the using layer or data in contains 13 layer. Okay, that means number of science data sets is layer 13, column and row is 2400 into 2400, and pixel size or spatial resolution is 500 meter. Okay, and layer description. Layer description, in the previous slide we have learned total layer is 13. Okay, so first layer is LC type 1. Okay, so that is the land cover type 1, annual international geosphere biosphere program, or shortly called IGBP classification. Okay, the data type is 8B unsigned integer, and field value is 255, and the valid range is 1 to 70. That means their class is available 1 to 17. Okay, and another layer also LC type 2, LC type 3, but in this video we have using LC type 1 that contains 1 to 17 layer, that means 1 to 17 class, and land cover type. Okay, 1, that is IGBP classification. Now how to access or where to access the data? So you guys can access the data from NASA Earth data search or the USGS Earth Explorer, but the NASA Earth data search is better because it is available for browse image, preview, direct download, order, search, subset. Okay, so let's start the tutorial. And you have new in this session, so in previously we have already make a video how to download the MODIS land use land cover data. You can see the video. After watching the video you can relate it from the two video. Okay, already we have created a video how to access the data. So now go to the software and how to classify the data in step by step. So this is the ArcGIS environment. Okay, so at first we have seen the data type. Okay, already we have discussed there is the 13 layers. So I have using that 3 data, that is format is HDF. Okay, dot HDF. So go to the data and add. So you guys can see the sub data set is 0 to 12. Okay, in previously described the total type is 13, And so in this video or in this tutorial we have using LC type 1 that contains 1 to 70 layer. Okay, so now you can see this type of layer. Okay, that's contain 1 to 17 layer, but in this tutorial I am using the model builder, because through the model builder you can process the data very quickly and large of data in short time. Okay, so remove from the layer. So before remove the layer, you need to a shape file. Okay, so that shape file or your study area, because after that it is need to clip process the data. Okay, why the shape file is carving? Because due to the sinusoidal projection. So again go to the blank. Okay, because you know whenever we add the layer in ArcGIS, that default projection is set. So now go to the this is my study area. One of the largest state, that is the Uttar Pradesh, and another is Bihar. Okay, so if you need to the shape file, please comment me. After the video I will provide the in description box. The link will be provided in description box. Okay, so to process the data, at first we have go to the model builder. Okay, and after the video, if it require, I also provided the model builder tool. Okay, so at first you need to your data means where you contains your data folder. Okay, so go to the insert and iteration and raster, because whenever your granular or data type 1, 10, 100 or more than, okay, then you can using this tool. Through this tool you can process the data very quickly. Okay, so at a time you need to input, and after that you can get the output. So go to the raster. So that is the iterated raster. Okay, then go to click here, and here is the workspace or raster catalog. That means where you store the data or the folder name. Okay, so now I select the only the folder. Okay, so after that you go to the raster format. You know the format is HDF. Okay, so click here HDF. Now go to the search button and search here extract sub dataset. Because the MODIS length use length cover granules have 13 layers, we need to specific LC type 1. Okay, that's why you need to this tool. So after extract sub data set, just give the input raster. Okay, after input the raster, you have go the subset ID. So you can see here 0 to 12, total 13 layer is available. So select the 0 because this is the LC type 1 that contains 1 to 17 classify layer. Okay. After that, go to output folder. So you need to create a output folder. Okay. So I have stored the data on my folder. Create a folder, sub data set. Okay. And type here percent name, again percent dot tip, because through the syntax the output name is given automatically. Very interesting. Okay. Save. Okay. So after extract the sub data set, you need to reproject the raster because the data is in sinusoidal projection. So type here project raster. So click here projected raster and give him the input name tip. Okay. And go to the output coordinate system. So my study area is fall in 44 north UTM zone. So you can select as your study area, it is fall in different UTM zone. So go to the northern hemisphere and select the 44 north. Okay. Then okay. Again go to the name of the projected raster. Again go to the create a folder and giving the name projected raster. Okay. Again type here percent name percent dot tip. Okay. Save. Okay. Now you have seen a magic. Just run the tool. You can see the automatically process the data. So now data is processed. Go to the projector raster and add the 3 layer. Okay, so now you can see the data is available on layer. So after reproject the raster, you need to mosaic the raster because there is the 3 different layer. Mosaic raster. Or type here mosaic to mosaic new data set. So mosaic to new raster, type here. So after that selecting 3 layer that is already reprojected. Sorry. Okay, then select the output location, mosaic. Okay, giving the name mosaic LULC dot tip. Okay. Oh, sorry. It's need to only the folder. Okay. Then go to the raster dataset name with extension. So type here mosaic LULC dot tip. Okay, then go to the number of bands 1. Okay, and cell size is optional, and mosaic operational is maximum, and mosaic color is fast. Okay, then click OK. So now you can see the data is available, okay, in mosaic. So after mosaic, you can go to reclassify, because the layer is 1 to 17. There is no particular thematic layer. To calculate area and giving the name, you need to the reclassify. So go to the reclassify spatial analysis tool, given the input raster. Okay, so reclassify is value, field is value. Go to the classify and go to the number of class is 17, because the LC1 data type layer contains 1 to 17 layer. Okay, so now no data is given as a no data. So then go to the output raster, create a folder, reclass, dot tip. Okay, save. Okay, now reclassify is running. Now go to the so this is the data, that is layer 1 to 17. Okay, so you can see value 1 to 17. Value 1 represent evergreen needle forest. Okay, so now you can see the value is from 1 to 17. So 1 represented evergreen needle forest, evergreen broadleaf forest, value 2 deciduous needle forest, okay, mixed forest, and so on. Okay, I will also provide the PDF in the link. Okay, so now go to the reclassify, open attribute table, and go to the add field. Okay, here type, class, name. Okay, and go to the text, and length is 255. Okay, now go to the editing and go to the edit feature, start editing, and giving the name one by one. Okay, so at first is evergreen forest, then evergreen needle forest, Then go to the mixed forest for value 5. Again go to close sharpland. So after that value 7 represented the open sharpland. Then go to woody savanna. Okay, then go to savanna for value 9. Then go to grassland for value 10. Then go to permanent wetlands. Okay, then go to croplands. Then go to urban and built up lands. Then go to for value 14, and value 15 represent the permanent snow. Okay, then go to the barren land. Then go to the 17, that is the water bodies. Now editor, save edit and go to stop editing. Okay, so now we have given the name. Okay, after giving the name you need to clip the data. Now question is, why at first we have given the name? Because somewhere not falling total 17 layers, here falling to 15, 14, 13. So at first I suggest you giving the name, after that you click the data. So go to the reclassify tick, then go to the extent. This is my study area, UP and Bihar, that is Uttar Pradesh and Bihar. Then go to the output name. I have put here clip data dot tip. Okay, save, and no data value is 0. So now you have seen the classify layer is available. Okay, so at first change the water body color like this. Okay, and go to the cropland in yellow color. Okay, and you can see here evergreen forest, evergreen broadleaf forest, deciduous broadleaf, mixed forest, open shrubland, woody savanna. Okay, so now you can see here total layer is 14. Okay, because the 3 layer is missing, because in all over world it is not covered the 17 layer, sometimes missing the layer. So now go to the add field and type here area. Now we have calculating the area, type here float. Okay, then go to OK. So now go to the check the pixel size. So now pixel size, check the pixel size to calculate the area in hectare. So now pixel size is 463.31225. Okay, so how to calculate the area in hectare? just go to the field calculator. Okay, so rule is pixel size into pixel size, okay, x into x into the count. Count means the number of pixel, okay, count means the number of pixel into count divided by 10,000 to calculate in hector. So rule is x into x, this is the spatial resolution, and into count, count means the number of pixel, okay, divided by 10,000. So area will be calculated in hector. So now your area is calculated. Okay. So evergreen needle forest is less area and the cropland is maximum cover the area. So hope you like the video. If you have any specific question for this video, you can write the down. After that I will reply you. Okay. So I think you like the video. If you like the video, please subscribe my channel and please share, like, comment also video. So thank you everyone. If you have any specific question, please mention on the comment section. I will reply whenever possible the time. So thank you everyone. Good night.